Alrighty then, corn children, children of the corn. It is a fine day for mathematics, and we're going to be looking today at the process of approximating the area of the curve under the curve using a left Riemann sum. All right, so that will be stated in the problem that is the technique you're using. So here's what you're going to be given. It's going to say approximate the area bounded by the curve f of x and the x-axis on this interval, and I'm telling you to use a left Riemann sum, that is left endpoint rectangles with 5 equal subdivisions. Okay, so let's do this. Here's the first thing we need to know. I'm going to really suggest you sketch this. So I have sketched our curve right there. Here's the parabola. It's up 1. You'll notice it's up 1. We are looking at the interval from 1 to 5. So there's this little gap over here that we are not using in the area. That is not going to be calculated. It's from 1 to 5, area under the curve above the x-axis. All right, so left endpoint rectangles, 5 equal subdivisions. Campers, we're going to start with those subdivisions. We need to cut this interval into 5 equal pieces. We're going to call that width delta x. So delta x, a small horizontal change in x, is our width. And here's how we calculate it. It is the end of the interval minus the beginning of the interval. That tells you how wide the interval is. That's a distance of 4. Yeah, there it is, 4. And because it said so, we are dividing it into 5 equal pieces. So the numerator comes from this interval, and the 5 comes from the 5 subdivisions. All right, so here we go. Doing the math, that's 4/5, also known as 0.8. That is the width of every single rectangle because they are equal subdivisions. So here's what we're going to do. We're going to go back to our picture. Starting at 1 because it said to, we're going to add 0.8 to the 1, and we will get, I'm just wondering if I should cut this up first. Well, we'll try. The math is going to be, there's 1.8. The math is going to be the accurate part, not my picture. So we're at 1, we added 0.8. We add 0.8 again. So 1.8 plus 0.8 is 2.6. We add 0.8 again. 3.4. We add 0.8 again. I did a pretty good job. 4.2. If you add 0.8 again, you should get exactly to the end of the interval. So each of these numbers has a distance of 0.8 between them. That's 0.8, that's 0.8, 0.8, 0.8, 0.8. All right, now here's the gig, people. We have been instructed to use a left Riemann sum, left endpoint rectangles. So if you take any 2 vertical lines, you will keep the height of the rectangle at the left corner. Okay, do you see it here? There are 2 vertical lines. I use the left one. Where the curve meets that vertical line is your rectangle height. Look at it, look at it, look at it. When you look at this rectangle, the left corner is on the function, not the right one. The right corner is just poop sitting there. And we're going to do it again. There we go. There we go. There we go. There we go. This is a left Riemann sum, not because the rectangles are below. Sometimes they are above. It is a left Riemann sum because the left corner is on the function where the right corners are not. Okay, alrighty then. So here's what we need to do. To approximate the area, we are going to add up the area of these rectangles. Last time I checked, the area of a rectangle was base times height. Hey, this first rectangle has a base of 0.8 right there. So does the second one, the third one, and the fourth one, and the fifth one. The bases for all of these, the width for all of these is that 0.8. So all I really need to do is figure out the heights. Okay, here we go. The height of the first rectangle. The height is the y value. It's the uppy downiness of that dot. Well, where is that dot? Well, it has an x coordinate of 1. I can see the x coordinate right here. To get the y coordinate, we would need to fill it into the function. Now, instead of actually doing the math, I'm going to say that the first height, now I'm going to write the heights. The first height is the height of the function at 1. Wouldn't that be the y coordinate right there? Yes, it would. What about rectangle number 2? Well, rectangle number 2's height is that much. How much is that much? It's the y coordinate of that dot. Well, how do you get a y coordinate? Don't you take the x and fill it into the function? Yes, you do. And we'd keep going. The next rectangle would have a height at 2.6. The x coordinate is 2.6. The y coordinate we would get from taking 2.6 and filling it into the function. I'll put it right here. Next up, height at 3.4. That height, the x value, the righty-leftiness of this dot is 3.4, but the height would be the height of the parabola, f at 3.4. And let's check the last one. The last one is the height at 4.2. I'd like you to notice that we're not using the height at 5. Is the height at 5 the height of our last rectangle? No. When we're doing a left Riemann sum, we would use the subdivisions on the left and not use the 5. Yeah. So if I take each and every height, multiply it by the width, and then add them all up, that would be our answer. But we're going to get a little fancy here. All right, here we go. So our area will be approximated by our width, which is the delta x, times each of the heights. I'm just going to distribute or use distribution notation here. F of 1, f of 1.8, f of 2.6, f of 3.4, plus f of 4.2. Now, if I hated myself, I could type all of these into my calculator, write them all down with like lots of digits to get the super duper accuracy and get my answer that way. I really don't want to do that. I am going to use sigma notation. Sigma notation. I have noticed that within the f ofs, there's a pattern. So consider with me, as a side note, the pattern. 1, 1.8, 2.6, and we're adding up 3.4, 4.2. This is a linear pattern. What do you mean linear? Well, to get from one term to the next, I have added 0.8 every single time. Whoops, 0.8. And because of that, it's a linear pattern. So, sigma notation. If you need to rewatch the video on sigma notation, please do so. All right, here we go. Because these are going up by 0.8, the formula to get these numbers will be of the form mx plus b, where the m is 0.8. So mx plus the b value. Now, easiest way to do this, if you begin with 0, filling 0 in, we would get 0 plus what? And the answer needs to be that 1. Well, ladies and gentlemen, it needs to be a 1. Check it out. 0 times 0.8 is 0, plus 1 is 1. The next number you'd fill in is 1. 1 times 0.8 plus 1 would get you 1.8. Then you'd fill in a 2, and you'd get here. You'd fill in a 3 and get there. You'd fill in a 4 and get the last one. So our last counter number is 4. Now, some of you are confused because you think there need to be 5 subdivisions, so you think this should be a 5. 0, 1, 2, 3, 4, is 5 subdivisions. 0 through 4 is 5 subdivisions. 1 through 5 would also work, but we're using 0 to 4. Now, this right here will get you this list. But here's the problem. We had that list filled into the f function. So what do? Fill this into the f function. Now it's f of all of that. What? Yeah, by putting f of, it puts those numbers inside the function. That's what the notation would mean. And what is that function? Here it is again. It was x squared plus 1. Oh, so wait a minute. Huh. If I have f of 5, it would mean fill in a 5 here. This is f of all of this. In this notation, everywhere I see an x, I replace it with that. Let me show you. Here's the function. It's right here. Look right here. Are you looking here? Instead of writing x squared plus 1, I will write blank squared plus 1. You see that? What goes in the blank? Oh, 0.8x plus 1. 0.8x plus 1. Yeah, big parentheses. Now, those are the heights. Don't forget that we need the heights multiplied by the widths, our delta x. If you take that to your calculator, you're going to get the right answer. At least I hope you will. Now, on my calculator, it's pretty nice. I can go to the alpha F2 shortcut key. It's the second one down. I'm going to go x equals 0 to 4, and I'm going to open another parenthesis, 0.8x plus 1, close it, square it, plus 1. Now, I have not typed the 0.8 here, so when I get this answer, that's not the final answer, times 0.8. And I get an approximate area of 36.16. Practice that. See how it goes.